All right, today we're diving into something pretty cool, the idea of an AI copilot for the super complex optical networks that, let's be honest, run our entire digital world. We're talking about engineering an autonomous network, so let's get right into it.
So let's just kick things off with a wild question. What if you could actually clone your network's brain? And I'm not talking about the hardware, the boxes and wires. I mean the real brain, the collective wisdom, the gut feelings, the years of experience locked inside the heads of your best engineers. What if you could bottle that up and have it working for you 24/7? That's the big idea we're going to unpack today.
Okay, so before we get to the solution, we've got to understand the problem, right? We need to look at why the folks in the network operations centers, the NOCs, are really feeling the heat. These teams are managing the absolute core of our networks, and honestly, they're getting stretched to a breaking point.
You know, optical transport is kind of the silent backbone of, well, everything. Your 5G phone, the cloud, streaming, all of it rides on these light-speed highways. But here's the catch. These networks are getting unbelievably fast and complex. The margins for error are razor thin, and the old way of doing things, people manually staring at screens and connecting the dots, it's just not cutting it anymore. It's starting to crack.
Yeah, this right here, this is the daily nightmare for a NOC engineer, especially in the world of DWDM. That's the magic that lets us cram insane amounts of data onto a single fiber. Imagine this. One little fiber cut happens, and suddenly, boom, thousands of alarms flood your screen. It's what they call an alarm storm, and it's almost impossible to find the real root cause in all that noise. You're jumping between like a dozen different tools, trying to piece the story together. And the worst part, the real how-to-fix-it guide is usually buried in some old playbook, or more likely, it's just stuck in the head of that one senior engineer who's seen it all. You can see why that's just not sustainable. It just can't scale.
And this just lays it out perfectly. We're moving away from what you could call human heroics. That one brilliant engineer who saves the day at 3 a.m. by just knowing what to do. That's not a business plan. We have to get to a world of autonomous reasoning. So instead of just reacting to alarms after something's already broken, the goal is to be proactive, to have a system that operates based on what you want it to do, your intent, and has all that human expertise already baked right in.
So, okay, that's the problem. It's a big one. So what's the answer? Well, this is where we introduce a really fascinating concept called the Optical NOC Twin. And you can just think of it as the smart AI copilot that these network teams have been dreaming of.
So what exactly is an optical NOC twin? It's an AI-powered digital twin, yeah, but, and this is the key part, it's not a twin of the physical network, it's a twin of your NOC's behavior. Think about that. It's a live working model of how your best people actually work, how they think, how they diagnose, and how they fix things.
And this is probably the most important distinction to get right. People hear digital twin, and they think of a model of the network's state. What's my current configuration? What's the performance looking like? And that's useful. But the optical NOC twin is a whole different beast. It models the behavior. It answers the question, how do we solve this problem? What are the exact steps, the diagnostic commands, the logical decisions that our top engineer would make? It's all about capturing the how, not just the what. It's a game changer. Okay, so how does this thing actually work under the hood? Let's pop it open and look at the engine. It really comes down to this powerful triad of three key technologies all working together seamlessly. And there's a really simple way to think about it. It's like a person. You've got the brain, the nervous system, and the hands. The brain is the AI models doing the thinking. The nervous system is the communication network that connects everything. And the hands are the AI agents that actually go and do the work. So let's take a quick look at each one of these.
First up, the brain. And look, this is absolutely crucial. We're not talking about some generic off-the-shelf AI. No way. These are precision-tuned models. They've been fed a very specific diet of your data, your past trouble tickets, your alarm history, your engineering runbooks. All of that gets digested, and it literally teaches the AI how to think and reason like one of your top optical experts. Okay, so you've got this brilliant brain. Now it needs a nervous system to connect to the body, right? That's where something called the MCP server comes in. Think of it as a universal translator for the network. It's a standard way for the AI brain to talk to everything, all the different tools, all the different vendor systems, and get the information it needs to make decisions. It's the glue that holds it all together. And last but not least, you need the hands to actually do things. And this is where it gets really interesting. It's not one giant AI trying to do everything. Instead, you have a whole team of specialized AI agents. You might have one agent that's a genius at sifting through alarms, Another one is an expert at analyzing performance metrics. And a third one is great at figuring out the right fix. And just like a real team, they all work together, orchestrated to solve the problem. It's pretty incredible.
All right, so we've seen the brain, the nervous system, and the hands. Now let's zoom out a bit and look at the big picture, the full anatomy of this NOC twin and how all these parts click together.
So, you can think of this architecture like a stack, built from the ground up. At the very bottom, you have that network digital twin we talked about, which gives you the real-time state of the network. On top of that, you've got the MCP integration layer, giving you access to all the tools. Then there's a really important piece called a knowledge graph. That's basically a smart map that understands how everything is connected, like how this customer's service depends on that specific fiber path. And then, sitting right on top, you have the brains of the operation, the agents, and the reasoning models that make all the smart decisions.
So let's put it all together. Let's walk through a real-world scenario super quick. An alarm pops up. Instantly, the system spins up the right team of AI agents for that specific problem. They immediately start using the MCP nervous system to pull data from everywhere they need to. They talk to each other, analyze the data, and pretty soon, they've figured out the root cause and have a solution ready to go. Then, and this can be either automatic or with a human thumbs up, the fix is pushed and the ticket is closed. And the amazing part? A process that could have taken an engineer hours of stressful work is now done in seconds.
All right, so let's get to the bottom line, the so what. Why does all this matter? Well, the impact of having an AI co-pilot like this is huge. We're talking about a fundamental shift in how networks are run.
The benefits are just massive. First off, you're crushing your mean time to repair. Again, taking problems that took hours and solving them in seconds. You also get to be proactive for a change. The AI can spot subtle warning signs and fix things before they break. And maybe the biggest win of all? That priceless, irreplaceable knowledge in your senior engineers' heads, it's finally captured. It becomes a permanent, scalable asset that works for you forever. That's a true game changer.
But there's a really critical point here that we can't just gloss over. The technology, the AI, that's actually not the hardest part. The real heavy lifting, the most disciplined work, is encoding how your people work. It's sitting down and mapping out precisely how your best engineers reason their way through a problem, how they think about fiber spans and performance margins and alarms. That human element, that's where the magic really happens.
And one last thing to keep in mind. This isn't some terrifying Big Bang project where you flip a switch and hope for the best. Not at all. It's an evolution, a journey. You can start small. Pick a few common, high-impact problems, build the automation for those, and let it run with a human in the loop. As you build trust and see the results, you gradually give it more autonomy and expand its scope. It's a crawl, walk, run approach.
So I want to leave you with this one final thought, and it's probably the most important question of all. The technology to build a NOC twin? It's here. It's real. So the big strategic question that every single network operator has to ask themselves is this. When your NOC twin goes live, whose expertise is it going to run on? Will it be your own, hard-won operational intelligence, or will it be someone else's? Definitely something to think about. Thanks so much for watching.